Hello friends, in this session we will discuss the subject fluid mechanics. Fluid mechanics is one of the most important subject for your GATE and engineering services point of view. In GATE you will expect more than 3 or 4 marks question from the fluid mechanics and 1 or 2 marks question from the fluid machines, which we will discuss later on. So in fluid mechanics, if your basics of thermodynamics is clear, then you will be able to understand the fluid mechanics in a great manner, in a very conceptual manner. So we will cover in the fluid mechanics complete syllabus of your GATE, started from the basic definition of fluid, then your fluid properties, then we can say the pressure measurement, then fluid static, followed by fluid kinematics, fluid dynamics, laminar flow through pipes, turbulent flow, right, and then boundary layer, dimensional analysis. This is the syllabus of the fluid mechanics which we will cover in this session. Now let us start with the basic definition of fluid. So if I write here that what do we mean by fluid? So fluid is a substance. If I write the definition, fluid is a substance which can deform continuously. This is important. Which can deform continuously when it is subjected to a shear stress or a shear force however smaller the shear force may be. This is the definition of your fluid. However, the smaller the shear force may be. So fluid is a substance which can deform continuously. This is important. Fluid will deform continuously when it is subjected to a shear force. If you apply a shear force on a fluid particle or a fluid, then it can deform continuously till that shear force is acting. Right, if that shear force is acting for, let us say, 10 seconds, then it is continuously deformed for 10 seconds, and when you remove the shear force or when you remove the shear stress, the fluid flow will stop, and fluid will stop at that point only where you remove the shear force. Right, that fluid will stop at that point only where you will remove the shear force, and fluid will flow or fluid will deform in the case if the shear force is very small. Right, if you apply a very small shear force on the fluid particle or on a fluid, your fluid in a container, then this fluid will deform continuously. However, the shear force will be very small. So we can say that if a fluid is at rest, right, if you say that the fluid is at rest, it is not moving, that means at that time the shear stress will be 0. At that time the shear stress will be 0, because if shear stress is there, then fluid will flow, fluid will move. If the fluid is at rest, that means shear stress is 0, and in that case only a normal compressive stress is acting. Only a normal compressive stress is there. And this normal compressive stress is known as pressure. As we discussed in the strength of material basics, that there is 2 types of stress. One is the shear stress and one is the normal stress. Normal stress is perpendicular to the cross section or the plane, and the shear stress is parallel to the plane or parallel to the cross sectional plane. So if the fluid is at rest, that means at that time your shear stress is 0 and only a normal compressive stress is present, and that normal compressive stress is known as pressure. We will discuss this point in detail when we will study fluid static, when the fluid is at rest. Just for your basic understanding, just remember this: if fluid is not moving, then only a normal compressive stress is there and only pressure is there, no shear stress will be present in that case. So we can say that, and we will see when we will study your difference between solid and fluid, that fluid is not able to resist this shear stress. If the shear stress is acting, then fluid must have to flow. There is no case that fluid is not moving under the action of shear force. Then when shear force is there, then fluid must flow. Then if we can say, what is the meaning of this deformation continuously? What is the meaning of this? If I can explain this with the help of a diagram. Suppose we can say, let us say that this is a fixed solid surface. Let us say this is a fixed solid surface over which your fluid is flowing. Right. Initially, I say that on this surface some fluid is present. These are the layers of fluid. We say that this fluid is present over this surface. Right. Initially, when there is no shear force acting on it, then this fluid is at rest. This fluid is not moving. Now let us suppose we take a section of fluid here. Let us say I take a section of fluid. Let us say this is the section of fluid which we have to study. On this section, let us say that there is 4 fluid particles. Let us say this is particle 1. On this layer, this is particle 2. On this layer, this is particle 3. And on this layer, this is particle 4. Initially, when there is no shear stress, all these particles are at rest. This fluid is at rest. When I apply a shear force, let us say I apply a shear force or shear stress, which we can represent with the help of letter tau. If I can apply a shear stress in this direction, then this fluid will start moving. This fluid will start moving, or this fluid will start flowing in this direction. We will study it later also, that this layer is the layer adjacent to this solid surface, or this layer is the layer which is in contact with this solid surface. So the layer which is in contact with this solid surface will achieve the velocity of this solid surface, and this is known as no slip condition. This is known as no slip condition. Right? No slip condition means there is no slip between the solid surface and the layer which is in contact with the solid surface. No slip condition means there is no relative velocity between them, between solid surface and this layer which is in contact with the solid surface. No slip condition means there is no relative velocity between them. So if the solid boundary is at rest, then this fluid layer which is in contact with this solid boundary is at rest. If, let us say, if this solid boundary is moving with 5 meter per second, let us say, so this layer is also moving with 5 meter per second, irrespective of the velocity of other fluid particles, irrespective. So this is known as no slip condition. So this particle 4 will not move. This will not move. Right? This will remain here. So on the application of shear stress, this fluid particle starts moving. Now let us say this is at time t is equal to 0 second. Let us say, I can say this condition is time at when time is 0. When time is 0. So if I say that if time is 1 second, let us say the fluid will flow, these particles will be like this. Let us say this is 1 dash, 1 dash, this is 2 dash, this is 3 dash, and so on. We can say that this is the condition when time is equal to 1 second. Shear stress is still acting, so after some time this fluid is continuously flowing. Then after some time, let us say this fluid will take this shape. The fluid will reach at this point. So this is 1 double dash, this is 2 double dash, this is 3 double dash, and 4 point will remain here. So this is time t is equal to 2 seconds, let us say. If further this shear stress is again acting, so let us say that this fluid will come here. This fluid particle will come here. This fluid layer will come here. This is 1 triple dash, 2 triple dash, 3 triple dash, and so on. This is when time t is equal to 3 seconds. And now you remove the shear stress. You remove this shear stress when t is equal to 3 seconds. Then fluid will remain at this position. The fluid will stop at this position. It will not move again in the forward direction. It will not regain its original shape. The fluid will stop here only. The fluid will not move in any direction if you remove this shear stress at t is equal to 3 seconds. Right. So we say that this is the meaning that the fluid is moving continuously if you apply a shear stress on the fluid element. So we know that this deformation, if you remember your strength of material, that this deformation, this angular deformation is shear angle or shear strain. So in fluid, this shear strain, this angle is continuously changing. This angle is continuously changing with time. This angle is when time is 1 second, this is when time is 2 seconds, and so on. Right. So this angle is continuously changing in your fluid element when it is subjected to shear stress. Now if I say if you will ask, sir, what is the difference between, if somebody asks, what is the difference between solid and fluid? What is the difference between solid and fluid? If you say that, what is the example of fluid? Fluids are of two examples, liquids and gases. Fluid are of two types, liquids and gases. There are three types of matter: solid, liquid, gas. Liquid and gas combinedly known as your fluid. So what is the difference between solid and fluid? If you remember from the strength of material, suppose this is a solid block. If I say and this bottom end of this solid block is stationary. If I fixed it, this is a solid block. If you name it, let us say this is A, B, C and D. And now if you apply a shear force on this solid, then because the action of this shear force, this solid will deform. So let us say this line AB will come to this line, will deform like this. This is point B dash, and C will come to this point. Let us say this is C dash. So the solid will, on the action of shear force, solid will deform like this. Now after the shear force, the shape will be A, B dash, C dash, D. And you know that this angle, this change of angle, this angular deformation is shear strain or shear angle. Fine. Shear angle or shear strain. From the basic definition of strength of material, we say that for a given shear force, you know that for a given shear force, the deformation, or you can say shear strain in solid is constant. Shear strain in solid is constant. For a given force, this angle is constant. Let us say, if I say for the 10 Newton force, let us say this angle is 1 degree. So this material, this solid object will deform by 1 degree under the action of 10 Newton force. You can apply this 10 Newton force for infinite number of time. For infinite time, let us say I apply this for 1 hour. So the angle will be 1 degree only. Angle will not change, it will be constant. But this is not the same for fluid. If I say that for the fluid, and you can also see from here that for the fluid, for a given shear force, your shear strain is not constant. Your shear strain is not constant. And you can also see from here that in the fluid, shear strain under a given force is a function of time. Shear strain is a function of time. As time increases, this angle will increase. But in solid, your shear strain is not a function of time. It is constant. That's why in solid we are, if you remember the strength of material, we are only saying what is the shear strain corresponding to a shear force, how much is the shear strain developed. But in fluid, as this shear strain is a function of time, so we will come into picture. There is a term come into picture, that is rate of shear strain. Rate of shear strain. That means the variation of shear strain with respect to time. Rate means with respect to time. So in fluid, we will deal with rate of shear strain because it is a function of time. But in solid, we will deal with only shear strain, not rate, because it is constant. And you also remember one thing from the strength of material, that if this shear force is within elastic limit, then you know that after removing shear force, if you remove this shear force, after removing this shear force, solid will regain its original position. Solid will regain its original position. It will regain its original position. If the shear force is within elastic limit, then when you remove this shear force, the solid will come back to its original position. But this is not the case with the fluid. If you remove the shear force from the fluid will stop at that point only. That if you remove the shear force at time t is equal to 3 seconds, the fluid will stop here only. It will not regain its original position. So the next difference between solid and fluid is fluid will not regain its original position. Fluid will not regain its original position after removing shear force. After removing shear force. Right. And from here you can see that the solid will have a tendency to resist this shear force. After coming to some particular constant angle, this solid will have a tendency to resist the shear force. But fluid will not have a tendency. Fluid cannot resist shear force. Fluid cannot resist shear force. It means that as long as the shear force is acting, fluid must flow. It is not like the solid that it can resist a shear force. So this is the difference between solid and fluid. So this is all about the basics of fluid. What is a fluid, how it behaves, and how it is different from solids, and what are the various points with respect to solids and fluids.